we're going to continue our discussion about rational functions graphs, and today we're going to focus solely on the slant asymptote, or also called oblique asymptote. And all these problems here are going to have those slanted or oblique asymptotes. So when we have those, we have to make sure we use long division, and that is our asymptote. And because the degree of the numerator is bigger than the degree of the denominator by 1, remember that's what we have right here, then the quotient will always be linear, and we're going to graph that line, and that is our asymptote. So none of these are going to have horizontal asymptotes. It will always be, these ones will always be slanted ones. Now, you might say, well, what do we compare then to for the end behavior? So for end behavior, for end behavior, we are going to compare f of negative 1,000 and f of positive 1,000 to the slant asymptote or oblique asymptote. So we're going to evaluate that asymptote at negative 1,000 and positive 1,000, and that's what we're going to compare f of negative 1,000 and f of positive 1,000. So when we graph these, we're still going to do all the same steps that we've done before. We're going to factor the numerator and denominator here. So we have x squared plus 5x plus 4. That factors to x plus 4 times x plus 1. The denominator is just x minus 3. We want to factor the numerator and denominator, again, just to see if we have anything that cancels out, which would give us a whole. Then our x-intercepts are going to be when the numerator is equal to 0. So that is going to be at negative 4 comma 0 and negative 1 comma 0. Then y-intercept, or y-intercept is f of 0, which equals 0 plus 4 times 0 plus 1 over 0 minus 3, and that gets us 4 over negative 3. So our y-intercept is 0 comma negative 4/3. Let's find our vertical asymptote. Vertical asymptote is what makes the denominator equal to 0, so x equals positive 3. And there is no horizontal asymptote because the degree of the numerator is larger than the degree of the denominator. So no HA. None. So now we're going to calculate the slant asymptote by using long division. So x minus 3 divided by x squared plus 5x plus 4. And we'll divide this, and x goes into x squared, x times. Oops. X times x is x squared. X times negative 3 is negative 3x. Then we subtract. This will give us 8x, and then we bring down the positive 4. All right, x goes into 8x 8 times. So then we get 8x minus 24. And then when we subtract, we get positive 28 as a remainder. Now, like I said, the remainder doesn't matter. It's this part right here. This is our oblique or slanted asymptote. All right, now we have to do the vertical behavior. So our slant asymptote, let's see where I want to write this. Slant asymptote is x plus 8. vertical behavior. All right, our asymptote is at x equals positive 3. So we're going to do f of 2.9. And that will give us 2.9 plus 4 times 2.9 plus 1 over 2.9 minus 3. So the numerator is going to be positive because we just have addition and we're adding a positive 2.9. The denominator is going to be negative because 2.9 minus 3 gives us a negative value. So negative, which means the left side goes down. And we know that since the multiplicity of our asymptote down here is 1, that the other end must go up because the end's going opposite directions with odd multiplicities. Or you could substitute in 3.1 if you wanted to. And you will see that you will get a positive, you'll get a positive value, so the right side up. All right, we're almost done now. The last thing we have to do is our end behavior. So we have to first evaluate the slant asymptote at negative 1,000. So negative 1,000 plus 8 is negative 992. And then we have to evaluate the slant asymptote at positive 1,000. 1,000 plus 8, 1,008. So when we do our end behavior and we substitute negative 1,000 in for f and positive 1,000 into f, we compare them to these numbers for above or below. So f of negative 1,000 is equal to negative 1,000 plus 4 times negative 1,000 plus 1 over negative 1,000 minus 3. When I type that into the calculator, I get negative 992.027, which is less than negative 992. So the left side is going to be below the asymptote. Then we're going to substitute in positive 1,000. So 1,000 plus 4 times 1,000 plus 1 over 1,000 minus 3. And I get 1,008.028, which is larger than 1,008, so above. So it's important that you match things up where the slant asymptote at negative 1,000 is compared to f evaluated at negative 1,000, and the slant asymptote at positive 1,000 is compared to the slant asymptote at positive, or the function at positive 1,000. All right, so now we have all our information and we're going to start with our sketch. All right, we have our x-intercepts at negative 4, 0 and negative 1, 0. We have our y-intercept at 0, negative 4/3, which is a little bit smaller than negative 1. We have our vertical asymptote at x equals 3. And now our slant asymptote is the equation x plus 8. So let's go up to 8 on the y-axis. 1, 2, 3, 4, 5, 6. And a slope of x means up 1 and right 1. So our slant asymptote is like this. So the left side of the graph, we have the left side goes down towards the asymptote. Let me draw that a little bit like that. And the left end behavior stays below our asymptote. So it's going to come up and back down. It looks something like that. Then this part over here is going to be above the asymptote and then go up. So as weird as that graph looks, that's the correct graph for this function with that slant asymptote. So yeah, this area here is completely, barren. There's nothing going on there because we have those two x-intercepts that we have to connect. All right, now let's look at the next problem. We have x to the third over x squared minus 1. So in factored form, we have x to the third times x minus 1 times x plus 1. And again, our degree is 1 larger in the numerator than the denominator, so we will have a slant asymptote instead of a horizontal one. So the x-intercept, we just have x to the third equals 0, so x has got to be 0, so 0 comma 0. Then our y-intercept. Our y-intercept is we're going to substitute 0 in for x. So we have f of 0 equals 0 to the third over 0 squared minus 1, which is 0. So 0, 0. So I substituted into this first equation here, and because we have equivalent equations or expressions for the same function, we can use either one at any time. Vertical asymptote. Okay, what makes these 0? X equals 1 and x equals negative 1. And like I was saying, we don't have a horizontal asymptote, but we have a slant asymptote. So we're going to divide x to the third by x squared minus 1. So we have x squared plus 0x minus 1 divided by x to the third plus 0x squared plus 0x plus 0. So how many times does x squared go into x to the third? That is going to be x times. Then x times x squared is x to the third. X times 0x is 0x squared. X times negative 1 is negative 1x. We'll subtract, and we're left with 0 minus negative 1x, which is just x plus 0. And we can't divide x squared into x, so we are done. This x plus 0 is our remainder, and our slant asymptote is x. Vertical behavior. We have two asymptotes here, but lucky for us, the multiplicity for each of them is 1, so we only need to calculate one end behavior for each of them. So for x equals positive 1, we're going to do f of 0.9. And again, you could use the factored form or you can use the original one. Factored form might be a little bit easier because you can tell positive and negatives without actually calculating. So I'm going to use that one. But if you're using a calculator, then the first one might be a bit easier. All right, so I substitute in 0.9. Well, the numerator is going to be positive. The denominator is going to be negative because we have that 0.9 minus 1. So that's going to be negative, which means the left side goes down. Then we have f of positive 1.1. And we know that it probably is going to, or it should be positive and go up. Oops, 1.1. 1.1 minus 1 times 1.1 plus 1, which is positive, so the right side up. Then we have to do the same thing for negative 1. So f of negative 1.1 equals negative 1.1 to the third over negative 1.1, negative 1.1 minus 1 times negative 1.1 plus 1. And the numerator is going to be negative because we have a negative number raised to a third power. And the denominator is going to end up being positive because we have a negative times a negative down there. So this is going to be negative left side down. And then f of negative 0.9. So we have negative 0.9 to the third over negative 0.9 minus 1 times negative 0.9 plus 1. Well, that negative 0.9 plus 1, that's going to be positive. And then we're going to multiply that by the negative factor, negative 0.9 minus 1. And then that negative 0.9 to the third power is going to be negative as well. So this is going to divide up to turn positive. So we got our vertical behavior. It is time for end behavior. So again, for end behavior, we have to evaluate the slant asymptote at negative 1,000 and positive 1,000. Well, luckily for us, since it's just x, that becomes very easy. It is just the value. Right, now our end behavior. And again, we can evaluate the end behavior in either one of them. I'm going to use the original, the non-factored one, because if I use the factored one, I have two spots where I have to type in 1,000 and negative 1,000, and it just makes it a little bit more prone to mistakes. So for end behavior, f of negative 1,000 is equal to negative 1,000 to the third power over negative 1,000 squared minus 1. And again, we type that in the calculator, we get negative 1,000.001, which is slightly smaller than negative 1,000, so we're going to go below. And then f of positive 1,000 is going to be positive 1,000 to the third over positive 1,000 squared minus 1, and that will give us positive 1,000.001, which is greater than 1,000, so above. So I know that all of this stuff is time-consuming and confusing. That's why we spent some time just identifying these characteristics before graphing the last few days. So let's go to our graph now. We have a vertical asymptote at positive 1 and negative 1. And we have a slant asymptote at y equals x. So here's y equals x. So the line looks like that. The only point that we have is 0, 0, our x and y intercept, and you see that's right on the slant asymptote, and that's okay. We know that. All right. Now, in between the vertical asymptotes, we know that the left side goes down on this one, and the right side goes up, and that this side comes down, and this side is going to come down too. And then we know the end behavior for both of these is that the left side is going to be below the asymptote. Left side right here, negative 1,000, below the asymptote, and the right side will be above the asymptote. So that's how our graph is going to look. So again, I know there's a lot of moving components to these graphs. let's go on to the next page. Now the next page, this one, or sorry, the next problem, this one we can't factor the numerator, so that does make this take maybe a little bit less work. So our intercepts x squared plus 2, we set that equal to 0. Well, when we subtract 2 from both sides, we get x squared equals negative 2, which we know can't happen. Now, yes, we could solve that and have an imaginary solution, but imaginary solutions don't equate to x-intercepts. So there are no x-intercepts. So we have to be careful when we draw our graph to make sure we don't touch the x-axis. Then we have the y-intercept. F of 0 is equal to 0 squared plus 2 over 0 minus 1, which is going to be negative 2. So our y-intercept is 0, comma, negative 2. Then our vertical asymptote, x equals positive 1. And again, there's no horizontal asymptote because the degree of the numerator is 1 larger than the degree of the denominator, which means we have to do our long division again. So x minus 1 divided by x squared plus 0x plus 2. X goes into x squared, x times, and then x times x is, x squared. X times negative 1 is negative 1x. We subtract. We get positive x plus 2. X goes into x one time. 1 times x is x minus 1. And then we subtract. 2 minus negative 1 is 3. And that's our remainder. But again, our remainder doesn't matter. So our slant asymptote is x plus 1. And then we'll come back and evaluate that at 1,000 and negative 1,000 after we do the vertical behavior. So vertical behavior, we're going to do f of 0.9, which is 0.9 squared, plus 2 over 0.9 minus 1. And that's going to give us a negative value because the numerators will be positive, but the denominator will be negative. So negative left side down, which means the right side, without doing this step, we don't have to again, but if we do, 1.1 minus 1, positive, so the right side is up. So we have now to evaluate our asymptote at negative 1,000, which is negative 1,000 plus 1, or negative 999 here. And then we have to evaluate our slant asymptote at positive 1,000, which will give us 1,001. Okay, so then let's now evaluate the function at negative 1,000 and positive 1,000. So vertical behavior, f of negative 1,000 is going to be negative 1,000 squared plus 2. Oops, we want to close these parentheses. Over negative 1,000 minus 1, which is going to equal negative 999.003, which is less than negative 999. So the left side is going to be below. Then we're going to evaluate at positive 1,000, so f of positive 1,000. That will equal 1001.003, which is greater than 1001. So the right side is going to be above. So let's go and graph our asymptotes. We have at +1, and our slant asymptote is at x plus 1, so we'll go to 1, and our slope is 1. So it's going to look like this. We have the point 0, -2, our y-intercept. Now our behavior, the left side, the end behavior is going to be below. So it's going to look like that. And of the vertical asymptote, the left side goes down. Now the right side of the asymptote, it goes up, and the end behavior is above the slant asymptote. So it will look like that. So most of the process is the same as our other rational functions. It's just that slant asymptote does take a bit more time to solve for. So thanks for watching this. Make sure to like the video and subscribe.